Game 7 and a video on the crusher, jaw crusher.
So the major unknowns that we had for the crush system, we needed to know what our jaw wear was going to be and if there was going to be any deformation on our removable steel blocks that we were putting in. We wanted to know the force required to fracture metamorphic rocks, the jaw tooth change-out design system, and then also what the optimal jaw motion would be for this crusher to break the rocks.
So this is the SolidWorks design that we came up with for the rock crusher. So notice there's two end joints here and offset shaft up here. So when this actually spins, the jaw doesn't move just in and out, it actually moves up and down. And that creates a shearing action on the rocks so it can shear them apart as it's crushing instead of trying to smash them, which is the key feature of the design. I didn't actually add it in this model, but we could split these rods and add couplings, and then by unscrewing and screwing the couplings, we would change the length of the rods, which would change the length, or change the size of the rocks that would actually come out of it. And we try to make it as manufacturable as possible, make it highly manufacturable. And one of the key points of actually making the model is make sure that it could be realistically assembled the way it is. Yeah, and so for this assembly, we didn't actually 3D print the jaws because it would have taken 20 hours to print them because they were so large. And this is a 1/4 scale model, so the model we came up with, it actually has a 12-inch by 24-inch jaws, so it's pretty large. A significant amount of lighting would have to be performed on the jaws itself. The way it's designed right now, actually weighs around 300 pounds, and it's only this big, but it's incredibly robust. So.
For the jaw wear, we figured that we needed to replace the teeth roughly every 2 to 3 months, depending on the use that it undergoes. And when we were looking for the crush and shear the rock, we had a range of strengths. We had a compressive being about 880 to 200 megapascals, while tensile was significantly lower, 10.5 megapascals, and the shear strength was a bit higher, from 15 to 50 megapascals.
And then, as Jacob's talking about the wear of the jaws, as well as the forces that it will see, the average compressive strength, tensile strength, as well as the shear strength. With that being said, now we have to move on to the idea of doing an analysis on it, and then really figuring out what sort of materials we can use and how machinable the materials we choose based on our analysis will be. On top of that, we plan on doing future studies with motion analysis because the jaw system that we decided to use isn't necessarily the most intuitive solution. However, that shear strength or the shear force that Sean was talking about will hopefully be really useful and allow our fatigue life to be much longer. With that being said, that is our presentation. Are there any questions?
So on your model, there's like kind of like a flat, well, on the actual prototype that you have right there, you just have like essentially a casing on the bottom. Where would you put the opening for the rock to fall through, and how wide would that be?
I mean, that would be something for the people that are designing the actual frame. Yeah, but it'd be directly underneath where the bottom of the base of the jaws come together. We'd want the slot to be right below it so that the rocks can drop straight underneath and then be caught by either a container or something and then removed that way.
Any other questions?
So maybe if one question maybe for you or for the power team. So who's responsible for? So you have the shaft you have is like say like 10-inch high, and your driving shaft will probably be 2-3 feet high at most. So who's gonna take that?
How do we combine
Right. Yeah.
ours
Right.
to the crusher?
Right. That's like who will take care of that?
I think we're in the middle of hashing that out.
Okay. Well, I mean, yeah, you still have time to talk about it, yeah, you need to decide that.
点。